Hello everyone, welcome to my video. Before you want to watch my video, let me introduce myself. My name is Luhde Kusumasari. You can call me by Luhde. So enjoy my video and let's check this out. So now I want to tell you about relation. Now, what is a relation? Relation means a set of ordered pairs that satisfy a relationship, or simply a bunch of points or ordered pairs. In other words, the relation between the two sets is defined as the collection of the ordered pairs, in which the ordered pairs is formed by the object from each set. And next, we talk about relation representation. Now, there are other ways to write the relation apart from each notation, such as through tables or relation in tables like this, plotting it on xy axis or relation in graph like this, and the last one is through mapping diagram or relation in mapping diagram or arrow diagram like this. Don't forget about types of relations. Different types of relations are as follows. First is empty relations. When there is no element of set X is related or mapped to any element of X, then the relation R in A is an empty relation and also called the void relation. That is, relation R is an empty set. For example, if there are 100 melons in the fruit basket, there is no possibility to finding a relation R of getting any apples in the basket. So R is void as it has 100 melons and no apples. Second is universal relation. R is a relation in a set. Let's say A is a universal relation because in this full relation, every element of A is related to every element of A. Or, that is, relation R is A cross A. Third is identity relations. If every element of set A is related to itself only, it is called identity relation. I is a set A, A belongs to A. For example, when we throw a dice, the total number of possible outcomes is 36. So, that is 1, 1, 1, 2, 1, 3, dots, 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 until 6, 6. From this, if we consider the relation 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. It is an identity relation. Fourth is inverse relations. If R is a relation from set A to set B, there is relation R, element A cross B. So, the relation R inverse equal to a set of all order pairs B, A such that A, B element relation R. 5 is reflective relations. A relation is a reflective relation if every element of set A maps to itself. That is, for every A, elements A, and then A, elements relation R. After reflective relations, there is symmetry relations. A symmetry relation is a relation R on a set A if A, B elements relation R, then B, A element relation R. For all A and B elements A. After that, there is transitive relations. If A, B elements relation R, B, C element relation R, then A, C elements relation R. For all A, B, C elements A. And this relation in set A is transitive. And forget, the last one is equivalence relation. If a relation is reflective, symmetric, and transitive, then the relation is called an equivalence relation. Let's understand this using an example of two sets. Now, we have two sets A and B. Set A has elements 3 and 6, and set B has elements 9, 18, and 20. We first take the Cartesian product of the two sets. Let's use an arrow diagram for the Cartesian product of set A and set B. So, A cross B is a set of the following order pairs. It's 3 pair with each of these 3. And then 6 pair with each of these 3. We get 6 order pairs of the form A, B, where every A belongs to set A and every B belongs to set B. Now, let's introduce a relation R. Relation R gives us a set of all order pairs that satisfy a relation. It could be any relation. Now, suppose we introduce a relation R dash such that B is a multiple of A. So we can say that relation R dash gives us a set of all order pairs A, B, where B is the multiple of A. Every order pairs in the set R dash satisfies the relation R dash. This is the set builder method to represent our dash. Please note that B has to be a multiple of A here. Now, let's choose order pairs from a Cartesian product A cross B that satisfies the relation R dash. This is the order pairs in the Cartesian product. Now, let's choose order pairs from a Cartesian product A cross B that satisfies the relation R dash is the order pairs in the Cartesian product. Notice such 9 is a multiple of 3, 18 is a multiple of 3, and also 18 is a multiple of 6. So, we get the order pairs 3, 9, 3, 18, and 6, 18, such that every order pair satisfies the relation B is a multiple of A. This is the roster method to represent set R dash. Set R dash can also be represented using an arrow diagram or mapping diagram, like this. We draw an arrow for every order pairs in set R dash. So, we draw one arrow for 3, 9, another arrow for 3, 18, and another arrow for 6, 18. And then, let's say this entire circle represents the set of elements in the Cartesian product A cross B. In that case, set R dash will be a part of it. We can say that set R dash is a subset of the Cartesian product A cross B. So, that is basic concept of a relation. Oh yeah, now let's talk about the terms imagined range, codomain, and domain. Wow! What is about imagined, domain, range, and codomain? Then, the first element forms the domain, and all the second elements form the range. What is the codomain here? The whole set B is called the codomain of relation R, so the codomain L will contain the elements 9, 18, and 20. Now, I want you to look at the range and the codomain and find a relation between them. What we can say? Yeah, we could say that the range is subset of the codomain. Okay, the last I would say that's all about relation. Thank you for watching. Don't forget to like, comment, and subscribe. Goodbye. See you in my another video.